Thank you everybody for joining us and welcome to our first virtual day of the Data Science Conference ADRIA 2024. Our first speaker is Mr. Amir Siddiqui with his topic document Q&A using LlamaIndex. Mr. Amir, the podium is yours.
Thank you so much for the introduction, and thank you Data Science Conference for giving me this opportunity to present this tech tutorial. So first I'll share my screen. I hope my screen is visible to everyone. So let's start with today's session on document Q&A using LlamaIndex. So first of all, I'll give you my introduction about my background, a brief introduction. So I work as a data scientist with T-Systems, and I'm having over 10 years of experience. I also have a YouTube channel on data science where I talk about the data science concepts, LLMs, LlamaIndex, LangChain. So this is my YouTube channel that you can go and have a look. And if you like the content, you can also subscribe to learn from there. So this is a very short brief about myself. And then talking about today's topic. So what we are going to cover is we will try to understand LLM, then LlamaIndex, what we are going to see in document Q&A, then RAG, what is the principle of RAG, what are the use cases that we can do, and what are the benefits of RAG, its architecture. And then we will also see code in our Jupyter notebook, that how we are going to implement this document Q&A using LlamaIndex in our code. So first, let's start with a very basic of LLM. Maybe you might have all heard about this LLM and ChatGPT. So as you know that these LLMs are large language models, so they are AI systems, and they are designed to understand human-like text information, and they are trained on huge amount of data that is available on public domain or the existing data. So whatever data is available, we can use those data and we can train these LLM models. And these training requires a lot of time and a lot of processing power. You must have a very good system to create your own LLMs. And then these LLMs are built on transformer models. So if you go back to our traditional machine learnings, or if you talk about NLP, natural language processing, so we have a wide range of concepts where we have transformers, architecture, encoder, decoder. Then there are various pre-processing steps for unstructured data, that is text data, that we use those steps to make it into structure, and then we use those information to train our model. And similarly in LLM, we use those same concepts of but the advanced concepts, and then we create these LLMs models. And the example of this LLM model is ChatGPT that everyone is using. Then from Google, we have Gemini. So earlier it was known as Bard, and now it is known as Gemini, and they have also launched their latest version. So these are the examples of LLMs. So what we do is these models are hosted on their platform. So when we use ChatGPT, the model is hosted on OpenAI platform. Then we make a call to those APIs, and in return, we get answers to our question. And similarly, if we take an example of Gemini also, so whenever we write our questions in the prompt, we actually hit APIs on Google server, and in return, we get the answers. So these are the examples of LLMs and their applications. And now let's talk about LlamaIndex. So why we have chosen LlamaIndex. Now, if you know about traditional machine learning, so in Python, if you want to develop your machine learning models, you use scikit-learn. If you want to make deep learning models, you use TensorFlow or PyTorch. If you want to do any NLP task, you use libraries such as NLTK, Spaces, then there are other some libraries. Now, if you want to create LLMs, then what you will use and how you can create your LLM applications, because you cannot use this scikit-learn. They are used mostly for machine learnings. So this is the framework, LlamaIndex and LangChain. These are the two frameworks that you will use whenever you want to create LLM-based applications. So LangChain is another application and LlamaIndex is another. They both are quite similar. They have some they have some differences, but almost they are same. So this LlamaIndex is a framework that you will use to create LLM applications, how you use scikit-learn to create machine learning models, how you use TensorFlow or PyTorch to create your deep learning models. So similarly, we will use LlamaIndex. And LlamaIndex has its own advantage. So in LLM also, you will have two concepts. One is RAG, retrieval augmentation generation, and the second concept is fine tuning. So these are the two concepts, and LlamaIndex is known for RAG. It has a very good RAG based applications that you can develop, and it supports a lot of functionalities that you can use to create a powerful RAG for your own private data set. So this is an application, or this is a framework to create LLM applications. And what are the use case of LlamaIndex? So you can use LlamaIndex to create RAG systems and drags. Then you have this document Q&A where you will upload your document, you will ask questions, and then you will get answers to your questions from your own document. And then there is also a concept of agents. So agents are nothing but when you want to get specific answers from internet, you use different APIs from different websites, then the agents interacts with those APIs and get answers to your questions. So this is about LlamaIndex. And let's talk about document Q&A, which is the topic of this today's session. So it is one of the most powerful applications of LLM because you can upload your private document and then you can ask questions. So if you have 1 page or 2 page document, you can simply read and then you know everything about the document. But what if you have 200 pages, 500 pages, 1000, 5000, or a lot of documents? So in that case, you cannot read all the documents and create notes. It will take you many years. So here, the concept of this document Q&A comes in place where you can use your PDF files, whether the information is stored in a PDF file, text file, or it is uploaded somewhere online or any JSON format or in any format. So you can use those data, create your chatbot. You can then ask question and you will get answers from your document. So it will help you a lot to get all the information within few seconds. And its applications are Q&A chatbots that are generally used to create using this LlamaIndex. Now, we will be using the concept of RAG to create document Q&A. So we must understand what is RAG. So the definition of RAG is retrieval augmentation generation. So what it does, we already have LLM models that we use in our day-to-day life, that is ChatGPT. So the difference is that in ChatGPT, all the data is from public domain, from Wikipedia or any open source, your newspaper or journals, anything that you find on the internet, the information present in those LLM models, ChatGPT, that is GPT 3.5 or GPT 4, they contain all the publicly available data. but they don't have information about your data, your PDF file, but you want to get answers from your PDF file. So what you can do in that case, one of the option is that you go and create your LLM, but that is very costly, very expensive. You will have to buy a very high-end computer, GPU, graphics card, and so on. So you cannot do that. The other option is RAG, where you will create a RAG application, then you will upload your files, and then you will create a chatbot for yourself, and then you will start asking questions to the files that you have uploaded. So what RAG does, it will enhance the existing capabilities of LLM. So whatever LLM models you are using, maybe it is Mistral AI, GPT 3.4, 3.5, or Gemini. So you will be using that model along with your data now. So that is possible with the help of RAG. So it understands your it understands data, and then it will generate text on whatever subject you provide to it. And your data is also safe because it will not go on the public domain. It will be within your server or within your organization. So it is safe also. So this is the use of RAG that will help you to create your own document Q&A, where you can use your private data set and start asking questions. Then what are the use cases of RAG? So these are 3 use cases that I have defined, but as every day we see new use cases coming in this area. So first is question and answer. Then the second one is search augmentation. So whenever you want to write any query and you want to search something online, you will be using this concept of RAG. It helps you to get relevant information based on a semantic search and then knowledge engine. So it is also like asking questions on your data, where you don't create a front-end application, but you just create a simple Python application where you can ask questions to your data. And in chatbot, you create a nice application where you will have a front end, back end, and everything will work behind the scene. So these are some of the applications, and there are many more applications coming. And what are the benefits of using RAG? Why you should use it? So it provides you up-to-date and accurate answer. And what does it mean? So if you have noticed in ChatGPT, when you ask some questions, if you ask any question about 2024, the output will be, or the answer will be, sorry, I don't have that information. I have information till January 2022. So the information that ChatGPT has, it is only till the year of 2022. It doesn't have information of 23 and 24, except GPT-4, which is a paid one, which is a premium. But what we all use is a free version that has GPT 3.5 LLM model, and that has information only till 2022. So with the help of RAG, we can add information from 2023, 2024, or whatever information you have got today. You can include those informations to your applications, and you will get answers for those questions as well. But that answers you won't get in ChatGPT, because that has information till the year 2022 only. Then the second one is providing domain-specific relevant responses. Now, if you go on ChatGPT and you ask questions, you will ask any question, any domain, whether you are from arts, science, commerce, business, trade, finance, anything. So it has information about all the topics. So you can say that it is jack of all and master of none, because it has information from all the domains. Now you want to create your own application which is domain specific. So you want to say that my application will know a particular about one domain only. Maybe it is finance, or maybe it is about HR, or science, or anything. So now your application will be more powerful because it will have data specific to your domain only. So whatever answer you will get will be much more better than what you get on what you get from this ChatGPT, because it has trained on all the data set, but you are providing only a domain specific, so it will be much stronger when you ask question about that domain. And the last one is being efficient and cost effective. So if you want to create a LLM model like GPT 3.5 or GPT-4 or Gemini AI, then you will have to buy a high-end machine configuration and so on. But to create a RAG, you don't need anything. You just need your simple laptop, and you can use any framework like LlamaIndex or LangChain, and then you can start creating your own application. So these are the major benefits of RAG that help you develop your applications being accurate, cost effective, and domain specific. Now, there are two options, as I have said earlier during the start of this session, that one thing is RAG, and the second is you can create your own LLM model, or also you can fine tune the existing LLM model. So when you should use RAG and when you should fine tune the model. So when you start learning LLM, and when you have just started creating applications, you should start with RAG because it is easy and it is flexible. Also, it takes less time to develop your application. But when you go with fine tuning, then it becomes difficult. You need to have a lot of time, lot of resources, because then you will have to create a model, train that model, and then you will have to test the accuracy of that model, and then you will use that model on your data set. But in RAG, we use the existing LLM models that is available, maybe GPT 3.5, Gemini, or Mistral AI. We use those models, but along with our own data set. So here it becomes very easy for you. You call those models, but provide your own data. But during the fine tuning, you have to first train your model again, and then you will go to the next step of providing your data set. So it is always a good idea, if you are an individual, if you are a learner, just go with RAG. If you have a startup or you have a company, then you can go with fine tuning, and you can create your models, or you can fine tune any existing models and use that. But for all of you who are here, RAG is the best one for you. Now, there are different applications of LLMs that you might have heard online or in newspapers or articles, posts. So we have concepts like prompt engineering, fine-tuning, pre-training, RAG, and also when you should use them. So if you look at this first one, so the method is prompt engineering, and its use case is when you want to use on the fly. So what we do when we write questions in our ChatGPT application, so that is our prompt, and whatever question we give it to is nothing but a kind of prompt engineering, where we try to explain or model that we want answers on these specific areas. Then the second one is RAG that we are talking about. So it is where you want to use your own data set. So you have information maybe in your PDF file, text file, JSON file, or any other file, and you want to use that information to create a chatbot or a simple document question and answering, where you can upload your document, and instead of reading those documents manually, you can get answers. So this is where RAG comes. Then fine tuning is you have to train a LLM model, and that takes a lot of time, and also it will require a very high-end machine. So that becomes very difficult for beginners and especially for individuals. Then the last one is pre-training. So pre-training is training an LLM from scratch, where you decide to create your own LLM, and that is part of pre-training. So these are some of the concepts that you will definitely hear in LLM. Then what is the architecture of RAG? How you can create this and how much time it will take for you, and what are the necessary steps that you have to take into considerations when you are talking about RAG. So it has two main components. The first one is indexing, and the second one is retrieval and generation. So if you have some knowledge about SQL, you must have heard about this concept of indexing in SQL, where whenever you want to query your database and you want to get the output in a much faster way, so you use the concept of indexing where you give numbering to your rows. So when you query your database, it becomes faster to get your results. The same application is the same concept is applicable here in RAG, where we will index our information or our rows. So whenever we want to query our data, whatever answers we get will be much faster. So the same concept of indexing that we see in SQL is also applicable here. And then second one is retrieval and generation. So retrieval is when you ask a question, it will go to your document, it will look for specific answers, and it will retrieve those paragraphs or those sentences where the actual answer is present. And once it has retrieved those answers from your document, the next part is generation. So if your RAG applications retrieve the answer, it will not copy paste as it is. It will then it will generate those answers. It will, modify, it will make it grammatically correct and everything. So that is the part of generation. First, retrieve, get the specific answer, and then generate that. Then modify that answer, then make it grammatically correct. So that is the part of generation. So these are the two main components of RAG. The first one is indexing. We have to create indexes. The second one is retrieval, get the answers from our document. And once we have the answer, then the next part is generation, where we will make those answers grammatically correct and in a much cleaner and nicer way, so that the user can interpret those answers easily. Now that was the in general architecture of RAG. Now we have LlamaIndex as a framework that we will be using to create this document Q&A using this RAG architecture. So how does the RAG architecture works in LlamaIndex? So if you go to LangChain, you will see there are some different steps. If you talk about LlamaIndex, then there are some different steps. So these are the 4 steps that you have to perform in LlamaIndex in order to create your RAG architecture to create your document Q&A. So what are these steps? The first one is loading. Second is indexing. Third is querying. And the fourth one is evaluating. So first part, let's go and explore this first part. So the first part is loading data. In this first part, whatever data you have, maybe your data is present in your PDF file, text file, JSON, or any other file format. So you have to load this data because you want to ask questions on this data itself. So the first part is you will load the data, then you will transform the data, and then you will index and store the data. So indexing, I will cover in the next slide. So you must have understood, you have to first load your data set. Once you have loaded your data set, the next part comes indexing. So in indexing, you will create indexes over these objects that are stored. And in LlamaIndex, we have something known as vector index function that we use to create indexing on this data set. So once you have created indexes on your data set, the next part comes querying. You will ask question to your data set. Maybe your data set is about LlamaIndex information. It has documentation of LlamaIndex. So you can just simply ask one question: what is LlamaIndex? how to install LlamaIndex in Python, because these informations are always available in the documentations. So once you have loaded the documentation, once you have created index, then you can ask these simple questions and you will get the output. And once you get the output, comes the evaluation part. So whatever output you got, whether the output is correct or not, how you will come to know? The one thing is that you can go and manually just go and check whether the two output matches or not. So that is the one thing, but you cannot do for all your questions. So we have some evaluation metrics also that can be used to evaluate the response, whether the response that we got or whether the answer that we got after querying our data is correct or not. And one of the evaluation metrics is faithfulness evaluator, and it has a value between 0 and 1. So if you get a value of 0, that means your answer is not correct. And if you get a number 1 or closer to 1, maybe 9, 8, 7, then that indicates that your answer is much accurate. So that part is the evaluation. Now we'll go to our Jupyter notebook and we will see how this works in LlamaIndex through our code. So this is my Jupyter notebook that I already prepared. Now, if you see, the first step that I have done here is loading the data. So in LlamaIndex, we have something known as simple directory reader. This class you can use to load any files, PDF, text, or any other. And here I am loading one PDF file and its name is muse.pdf. And I'll show you what is that PDF file is about. So this is the PDF file, and this is nothing but a research paper, Muse, text to image generation via mask generative transformers. So we are loading this PDF file, and then there are so many contents here. So we have this abstract, introduction, and we will have some pre-trained text encoders, model. So these are the paragraphs, base models, semantic tokenizations using VQGAN. So these are some of the headings or some of the concepts that are present in this research paper. Then once we load this data and once we prepare it for question and answering, we will ask these questions. What is pre-trained text encoders? What is semantic tokenization using VQGAN? So we will see whether we are getting answers or not from this document. So this is a PDF file that I have loaded here. And you will just need this two steps here only to load this PDF file. Call this class simple directory reader, then pass this file, and then you will call this load underscore data method here, and then you will have your document loaded. So if you see here, first you have this document ID, and then you have metadata. So metadata will have information about your PDF file. So the file name is given here, then file path where it is located, and then you have creation date, what is the file size, last modify, and everything about this file. And from here, you will see the text that we saw in the document. So this is the Muse text to image generation via mask generative transformers. This was the headline that we have already seen. Then these are some of the names of authors, I guess. And if I go back to this PDF file, so yes, you will see these are the names of the authors that we see here. So from here it is starting. So this is /new, it is from new line. So these are the names of the author. And this is the complete PDF file we have, from which we are going to ask questions and we will get answers. So we have done the first step. Now the second step is to create LLM model object. And here we are using Mistral AI model. It is one of the a very powerful model that you can use. And the best thing about this is it is free. You can use this using Hugging Face. So if you have your account on Hugging Face, then you can simply go there on Hugging Face, and then you can just use it. So if I come on this Hugging Face here, so here you will type Mistral AI. So this is the model that I'm using here. And this model you can also use. You can come here and then you just have to copy from here and then you have to use it. So this is what I'm using here. Now, why I'm using Hugging Face Hub, why I'm not using OpenAI? Because if you use OpenAI, it is not free. You will have to uh, give details about your credit card. And whenever you make a call to Open API, you will have to pay for that. So that is why I'm using Hugging Face here, because on Hugging Face, you can use this model for free and you can create your RAG application for totally free. You don't have to pay a single penny. You don't have to provide details about your credit card or anything. You just have to create your account on Hugging Face. That will take only 2 minutes. And once you have created your account, then you have to go to this settings here. And in settings, you will come here. You will see this section of access tokens. And here you can create your new token. So these are the tokens that I have already created. I can even create a new token. I can just name it anything, maybe example token. And then you can choose whether it is read or write. I'll just select write, or you can also select read. It doesn't matter. Then you have to click on this generate token, and this will generate a new token for you. So you see there, I have generated a new token and you can use this. And if you think that this token is exposed somewhere, so you can also delete it. You will click here and then you can just delete it. So you will click on this confirm and just delete it. So make sure that whenever you are creating this API keys or these tokens, please do not share it with anyone, because one of the reason is this Hugging Face is free, but if you have this API keys from OpenAI, in that case, if somebody else gets your API keys or your tokens, then they will start using it and you will have to pay for their charges. So always make sure that you do not share your tokens with anyone, and keep deleting your tokens after some time, so that even if by mistake it is exposed to someone, it gets deleted. So you have to import this Hugging Face Hub, and then you have to import this login. This is get pass. Get pass is when you pass your API keys here, then users cannot see your API keys. And what you see here in dot 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 are nothing but the API keys that I've passed here. So once you have this, then to use these models from Hugging Face, you will be calling this Hugging Face Inference API library. Once you have this, then you have to create an object of this and store in a variable. Here I am saving it in LLM. And inside this, you have these two parameters. The first one is you have to provide your model name. And here I am using Mistral AI model. And then the second one is token that I have already validated here. So these are the two parameters. And now I have created this LLM model, or I am using this LLM model. This is just an object and this model is already available. So I have created an object of this model, and now I can use this Mistral AI later to get answers from the document. And once I print this LLM object, I will get some information like this. So we have this information like model name. So here you see model name here. Then we have token. So then we have timeout and so on. So this is a token that you have to hide. I will delete it after this tutorial. Then the next part is we have to create indexes, as we have already seen in the PPT. The first part is load your data set. Next, second part is create index. third is query your data. So what we are doing here is we are creating index here. And to create an index, we are going to use a vector store index from LlamaIndex. So we will call this vector store index that we are importing here. And from this, there is a method called from documents. And inside this, we have to pass our document. So our document is here. That is our PDF file is here. So what we will do, we will pass our PDF file and then we have to create embeddings. So embeddings are nothing but we convert our text into numbers. So what we are doing here, we are passing our document and then embed model. And there are many embedding models. So there is also an embedding model from Hugging Face API. Then we have embedding models from OpenAI. So many sources of embeddings are there. But here in this case, we are using local embeddings here. So using this local embedding model, we will do the embedding of our PDF file, and this will create an index for us, and this will store the index at this location that we see here. Now, once we have created this index, the next part comes the querying of the dataset that we saw in the PPT. So to start querying our dataset, we will first create a retriever. And to create a retriever object, retriever means it will go in our document and it will retrieve the data. So here we will come and we will use this vector index retriever here. And then in index, so these are the parameters. The first one is index. And in index, we will pass our index that we have created here. And the next parameter is similarity top K. So this parameter is when you get answers, how many documents you want. So when I am writing here 5, it means that in the output, I will get 5 answers. And out of the 5, in the first document, I will have the most accurate answer, followed by second, third, fourth, and fifth. Maybe in most of the cases, what happens in our first document, we have the accurate answer, and in the second, third, fourth, we actually don't have the accurate answer and they are not relevant. So here you can change the value. Maybe you can keep it 5, you can make it 1, 2, or even 10 or 20. It depends on you. But you will always get accurate answer in your first document only. And once we have this retriever object, now we will use this response synthesizer. So this will help us to use this LLM model that we have created above. So this LLM object that we have created above, this will help us to use this LLM and query our data set. And also the response will be in a much nicer way and also grammatically correct, so that we can interpret that answer and it will be easy for us to read. Now, we will use this retriever query engine to create a query engine. So to get your answers, first we have to create a query engine. So first is indexing, second is retriever, and now the last one is query engine. And here we will pass all of this. That is, we will pass our retriever here that we have created, then also this response synthesizer that we have created here. And once we have passed all of this, then we will create our query engine object. And this object we will use to get answers from our data set. And now we have this query engine. So we will start asking questions. Now I have created one variable here, response. Then I have called this query engine. And from this, I will call this method query. And now let's start asking question. So the first question that I have asked is, what is image to text generation? Because this paper is about text to image generation. So first I will ask it about not image to text, but text to image. So I will just correct it, text to image generation. and let me execute this code. So it should give me an output. And because this notebook was idle, but yeah, we got the answer here. So it says that text to image generation is a process of creating images from textual information, textual descriptions. It involves training a machine learning model on a large data set of image text pairs, where the text describes the content of the image. Once trained, the model can generate new images based on textual input, such as sentence or a phrase. This technology has various applications, including content creation, data augmentation, and visualization. So this was my first question that I've asked. Now, the second question that I have asked is, what are pre-trained text encoders? And this also you will find in the document somewhere. So if I go to this document, and we will have this, yeah, so we have this pre-trained text encoders here. So this is what I have asked here. I can even rerun this. So the query is, what are pre-trained text encoders? And let's look at the output here. So it says that pre-trained text encoders are models that you have been trained on large amounts of text data and can be used to encode text inputs into a vector space that can be used for various downstream tasks such as text classification, text generation, and text to image generation. And this is the paper is about text to image generation. So we are getting the answers from our document. The next question that I have asked is, what is decoder fine tuning? And this is also a part of this document. If I go to this document here, so we will see somewhere, yeah, so this is decoder fine tuning. And this is what I have asked here. So it says that decoder fine tuning is a technique used to improve the ability of a model to generate fine details. It involves increasing the capacity of VQ-GAN decoder by the addition of more residual layers. And if you compare it with our PDF, so here also you will see it is talking about VQ-GAN, and here in the output also we see the mentioning of this VQ-GAN. So this answer is what we are getting from our PDF file. Then the next question that I asked is, what are image generation models? And this is also we will see somewhere here. So I can just search here, image generation models. Yeah, so we have this paragraph, image generation model. And here also they are mentioning about this GANs. And if we look at the answer, so here also you see in the output we have this image generation models are machine learning models that can generate new images from random noise or a given output, and it includes this VAES and these GANs and diffusion models. And here also you see about this GANs and then other things. So we are getting the answer from our document, and let's say I can also create a new one. I'll just copy it from here and then I'll paste it here. And now I will ask about this image tokenizers. So I will just write here, what are image tokenizers? And we should also get a response for this question as well. So it says that image tokenizers are useful for multiple generative models due to the ability to move the bulk of the computation from input pixel space to latents, a number of tokenization approaches such as, and so on. So if you compare it with this one here also, if you see, they are talking about this pixel, then VG, VQ GAN, then VQ VAE, and here also you will see VAE, VQ VAE. So whatever answer that we are seeing here is nothing but we are getting from our PDF files. Now, these answers can also change. If you see that whatever response that you are getting is not correct, then there is a concept called chunking. So that we have not included here, but you can include that here. So what we do in the process of chunking is that we have this entire document as one. In that case, we will split our documents into different sub-documents based on some numbers. And based on that, it will create several different documents. And then instead when, now what we are doing is when I am writing a question, it is going and searching in the entire document one by one. So it is taking time. But when I create chunk, it will split this document into different paragraphs. Maybe it will create 10, 12, 15 paragraphs, whatever number I pass. So based on that chunks, it will then give me output. So in that case, if you see that you are not getting a good answer, then you can just, play around with that chunk size number and see with what is the chunk size from which you are getting a good response. So that is one thing that you can try from your end. And then after that comes the evaluation part. So evaluation part, I have not included in this notebook here, but the next part will be of evaluation, where you can just evaluate your answer and see what output you are getting. So for example, if you use this faithfulness evaluator, so you just have to write 2-3 lines of code here and then call that faithfulness evaluator and see what value you are getting. If you are getting a value of 0, that means your answer is not correct. If you are getting a value which is closer to what, maybe 1 or 9 or 8, that means your answer is correct. So if I summarize you in short, these are the very basic steps, or very simple approach that you can use to create your own RAG application or your own Q&A chatbot. So after that, you can create your front end and your back end, and you can integrate this notebook after converting this into a Python file. So now you must be noticing that it's so easy to create your own application. You have to first just read your or load your data set, then create indexes, then make this retriever. These are just a few lines of code and you are done. You can start asking questions and you will get response. And this is nothing but document question and answering, where you provide your own document, you ask questions and you get your answers. So that's all I wanted to share with you. And now if you have any questions, please feel free to ask. I would be very happy to answer you. And also I would say that if you want to get more a deeper understanding, then you can definitely check out my YouTube channel, where I have created a lot of videos on LangChain as well as LlamaIndex that will help you a lot. So let's take question and answer from all of you. Please feel free to ask any questions. I think you can write your questions in this chat box and I'll reply. Yes, I can share this presentation with you and you all can download. Maybe I think, upload it here. Yes, I can upload it here. I'll upload. And yeah, about my YouTube channel. So YouTube channel name is StatsWire. You can, I think if you can see this logo. And I'll try to send. I'm not sure how I can share with you, but I'll just upload it from my side. So I've shared this in the chat.
You shared it with host and panelists. I'll share it now with everyone else.
Okay, great. So I've shared this notebook and I'll also share PPT. PPT I've shared, I'll share notebook and also PDF file that I've used. Yes, I've shared everything.
The documents are available in the chat for everyone to download.
Yeah, thank you so much for sharing with everyone. Feel free to ask any questions.
And also under Q&A, I answered to the question for the YouTube channel with a link, so anyone interested can check there for the YouTube link.
Thank you for sharing with everyone. If you have any questions or any feedback, you can feel free. Okay, so embedding is when we convert our text into numbers. So that is embeddings. And when we index, when we give or when we arrange our numbers for querying, that is indexing. So indexing is nothing once we have these embeddings and then we want to order those embeddings so that in a way that it becomes very easier for us to query and get the answers as fast as possible. So indexing is just the ordering of embeddings.